All right, back for video 2. We're just going to do a continuation of what we were already talking about and add a little calculator piece in. So if you don't have a calculator, now would be a great time to get one. We're going to start out with example number 4. Again, you're given a right triangle with side lengths 20, 21, and 29. And we want to find the sine, cosine, and tangent of angle A. And we want to round our answers to the nearest hundredth. So hundredth would be 2 decimal places. We want to find the ratios to the nearest hundredth. Right now would be a great time to pause the video and find the sine, cosine, and tangent of angle A rounded to the nearest hundredth. And then when you unpause it, I will have the answers up on the screen. All right, here you go. These are the 3 ratios you should have: 20 over 29 for sine, 21 over 29 for cosine, and 20 over 21 for tangent. Now, using your calculator and rounding your answers to the nearest hundredth, sine of A should be approximately 0.69. Cosine A should be approximately 0.72. And tangent is really close to 1.95. All right, so hopefully you got those 3. Again, just using our SOHCAHTOA, sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. SOHCAHTOA. There are your 3 trig ratios for the acute angle, angle A. All right. Let's move on to examples 5, 6, and 7. Again, what I would do at this point is go ahead and pause the video, get these examples into your notes, draw them as they're drawn on the screen, and find the sine of angle C in example 5, the cosine of angle C in example 6, and the tangent of angle X in example number 7. And why don't we do the exact ratios as well as the decimal approximation to the nearest hundredth again. Again, so take some time now, pause, do these 3 problems, see if you can do them out. If you need to write SOHCAHTOA down on your paper so you remember the ratios, or go back to some of the other examples, do so. But give them a shot and see what you get. When you come back, the answers will be on the screen for you. All right, here you go. Sine, cosine, and tangent for the 3 angles that are asked. Example number 5 might look familiar. I think it actually came from example number 4, so hopefully you got that one right. Number 6, though, 8/17 is approximately 0.47 for the cosine of angle C, 8/17. And then tangent X would be opposite over adjacent, so opposite of angle X would be 36, adjacent would be 27, for a ratio of 1.33. Hopefully these 7 examples have helped you become comfortable with the basics of sine, cosine, and tangent. Again, writing the ratios, identifying the lengths of the sides, and then just using your calculator to get a decimal approximation, be it to the nearest hundredth, thousandth, 10,000th, wherever you need to be going. We're going to move on now to talking about another piece that is associated with this. And again, this is where you're going to need your calculator. All right, just a quick picture of a calculator here, typical of what you guys have. And what I want to point out to you is just some things that are located on your calculator that we are going to be using. Sine, cosine, and tangent occur right here on this calculator, and every scientific calculator has one. Oddly enough, people have asked me before, and I'm not 100% sure as to what the answer is, why they don't put the E on the end of sine, why they don't spell out cosine. Probably just keeping things as 3 letters is easiest. But these are the sine, cosine, and tangent buttons on your calculator. And they are used when you know an angle. You can find the sine, the cosine, and the tangent of that angle. You can find the ratio of the sides for opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, regardless of the size of the triangle. As we saw in the last video, it doesn't matter that two congruent angles will always have the same sine, cosine, and tangent. We're going to use these three buttons to look at a couple of examples now, and it's going to be really straightforward and easy. It's just kind of pressing the button in the right order and making sure that you do it right. So get your calculator out and get ready to go. Here we go. The questions here are simply to find some values of the trig ratios rounded to the nearest 10,000th. 10,000th is what we're looking for. Tenths, hundredths, thousandths, 10,000ths. So we're going to be going to 4 decimal places. And we're going to be using the sine, the cosine, and the tangent button on your calculator. So here we go. Let it be known that I will be a stickler when it comes to rounding, that we should all get the exact same answers for these, that they shouldn't really be close to each other. They should be exactly the same because we know how to round. So rounding to 4 decimal places. Sine 62. Depending on the calculator you have, you may have to enter 62 and then press the sine button, or other calculators, especially the graphing calculators, will allow you to press sine followed by the 62 and then enter. And it will tell you the ratio of the opposite side to the hypotenuse for any 62-degree angle. And that ratio should come out to be 0.8829. So 0.8829 for the first one. And again, we should get the exact same value, not 0.8828, not 0.8830, 0.8829 is the rounded value to 4 decimal places. Take a second and see if you can get the sine of 14. I get 0.2419. And again, that should be a value that we all get, that it should not be something close to that, it should be exactly that. Again, that says that the ratio of any triangle that has an acute angle of 14 degrees, the ratio of the sides of the opposite to the hypotenuse in that right triangle will always be in the ratio that produces a decimal of 0.2419. The same is going to be true about the remaining 4 examples. It's just about pressing the buttons and knowing what button to press when. So we want to find the cosine of 60 and the cosine of 31. Before I do that, I do have to just say this. If you did not get those 2 values, one of the things that you might want to do is on your calculator, sorry, there's snafu there. Check to see whether or not your calculator is in degree mode or not. If you have a graphing calculator or a fancy one, if you just hit the mode key, you want to make sure it says degrees. If you have one of the scientific calculators that has a DRG button on the top of it, you want to make sure that it says D. If you're unable to figure out how to do this, bring your calculator in and I will definitely take a look at it. So cosine of 60, cosine of 31, go ahead and bang those out, see if you can get the decimal to the nearest 10,000th for those. I will write them here. For number 9, cosine of 60, it is just 0.5. I guess if they wanted it to the nearest 10,000th, we could put the zeros in. I'd be fine without the zeros. So either 0.5000 or just plain old 0.5 is cool by me. If you're a fraction buff, go ahead and give me a half, and I'd be even happier. For 31, 0.8572 for the cosine would be the ratio of the adjacent to the hypotenuse. And then finally tangent, the last 2, tangent of 79, 5.1446, and tangent of 25.4663. Yes, 0.4663. And there you have it. There you have using your calculator with sine, cosine, and tangent to evaluate those ratios. And in the next set of videos, we'll look at how we use this information to help find missing sides in a triangle. All right, I hope all is well. Hope this gets you through all of your in-class work tomorrow. Thanks. And, just want to point out that the Mets did just beat the Yankees again.